All right, so I'm Tom Steele. Currently, I'm a senior security consultant at Bishop Securities. I do a lot of open source code and projects like that, and I also speak on them quite a bit. So if you guys are at any other cons this week, I'll be speaking at those on a different project. And then my main job role at Bishop Securities is pen tester. So mostly using the tools that we've been talking about here to break into companies day in and day out. So this is a talk about complexity, not about storage or how to measure strength or even how to measure complexity. It's about how to enforce it, not how to enforce it. So I'm going to be providing a tool that lets you enforce password complexity, but I'm not going to tell you how to enforce it, if that makes sense. So I'm not going to tell you exactly what you should allow, what you should allow, etc. Yes?
Do you recommend 50 kilovolts or 100 kilovolts?
So if you like the tool at the end and you are looking for someone to tell you how you should use it, luckily there's a bunch of smart people in this room that I'm sure would only charge you a small fortune to do so. So talk to them. Okay, so how we enforce password complexity today, typically, is filled with good intentions. And by good intentions, I mean when Microsoft created their recommendations online about how you should enforce password complexity in your Windows domain, for instance, I'm assuming the person who wrote that and the person who designed it had very good intentions. You know, we want one uppercase letter or one lowercase, or 3 of the 4, right? So it's one special, one number, one uppercase, and then 8 digits or 8 characters. But this is what good intentions get you. They get you password 1, password with an @ and I hope not at fishnet 1. I hope that doesn't exist, but it might. And so what these get you is not very good passwords, but they're also very, very predictable. So like I said, we break into companies on a daily basis, and oftentimes we do it through guessing passwords just like this. What we do is very simple: build a list of usernames or email addresses, and if you have an authentication interface in the perimeter that isn't protected by some sort of 2-factor authentication, such as a webmail or a VPN, we just loop through each one of those usernames, and typically someone has a password like this. Very, very common. They also work on online attacks. If you're on an internal network and you should happen to capture a hash off the network, typically it might be something like this. You can also do guesses on the internal network against a domain controller, etc. Other issues that they get you. This is just not really an issue with the good intentions behind some of the password complexities. Just dictionary tags typically work very, very well. There's, every single time that we're on a test or trying to break into a network and we can capture a hash, typically we do dictionary tags first, and we only want really one, so those typically work. And even if the hashing algorithm is very, very good, if it's in a dictionary, it doesn't take us long. So a good example is the net and version 2 that you can get through things like net files and things like that. It's a very slow hash to crack, even with some really beefy systems. But if that hash is in a word list that we've already obtained through someone else crafting them and stuff like that, like a LinkedIn list or the Rocky list, etc., doesn't really do any good. You can still just crack it and it's fine. So how can we fix this? Like, what sort of tools can we use? What sort of methods can we use? Well, we can use user education for at least picking a good password. Doesn't really help against the word list because there's still some really good passwords in those word lists. Well, I would say good. If you don't decide that they're good, that's fine. But so we can educate users to pick good passwords. It's not really a good way of doing it, but you have to do it. You kind of hope. But the problem is there's always someone who's not paid enough to care, or they just don't care because they're on their way out, or they're new and they didn't get the training. There's just basically someone that's always going to fail this. And it's of the password complexity training that I've seen. But you should only focus on why you should, or how to choose a good password, not why you should. And choosing not very good advice. So that could certainly be some improvements as well. And the next kind of one is just having stronger complexity requirements. And currently, some examples of how you can do that are like Windows group policy. OAuth has some libraries for Java and PHP. I'm sure there's some other language-specific libraries. And then there's a tool by Solar, I think, that is for Linux that basically integrates with a PAN module that can do some of the complexity requirements. Does anyone see the problem with these? The ones that they can immediately put out. The problem here is that these are very, very specific to the implementation, meaning Windows group policy is obviously only going to work for something that connects to the domain or the Windows system. The OAuth libraries are only for the two Java and PHP. The last one, I've seen some hacky code that can kind of tie in PHP to Linux PAN modules and kind of do it, but again, you're reduced to only a single language. And in today's environment, the amount of systems we have, the amount of applications that we're using that might use like not something like not single sign-on that's tied to the domain, for instance, there's just too many places where you have a password and you kind of need a universal way to do it. So that's what I created. I created this, basically it's called a language agnostic web service. Basically a password complexity service that uses HTTP over TLS, which will kind of do some things to tell you if your password passes or fails the test that it has. It's written in JavaScript on top of Node and uses Redis as a memory data store. So one more time. So I'm going to have to move over here to do the demo. Hopefully I'll try to speak loud.
It's a wireless mic, I think we can use.
Oh, okay. Yeah.
We're away.
Also 12 feet back.
Yep. Okay. Cool. All right. So everyone can see this, right? Okay. Cool. So the best way to kind of explain what it can and can't do is to simply look at the config of the application. So the way it works is it has a bunch of different tests that it can do, and you configure them in this JSON file before you start up the service. The first thing you see is the max length. This simply, you can give it a value of, okay, if the password is a certain length, I'm going to say it's good. Now, I put that at 20, that's arbitrary. That's up to you to decide what you should do. And all of these are kind of like that. We also have, so now to the things that it can do, the checks that it can perform on a password. The first one is minimum length. That's pretty self-explanatory. The next one is key walk. So what key walking is, and it only does it right to left, but key walking is someone choosing a password by simply walking their hands along a key. So it might be 1, 2, 3, 4, EWERT, or right, so it might be TREW, etc. And so you basically set that you want it enabled, and then you set an allowed amount. So once it hits 4 characters in a row, left to right, it will fail the password. The next one is your traditional complexity requirements, which is you must have 1 lower, 1 upper, 1 digit, 1 special. And then this one's probably one of my favorites. Is actually can have masks. So typically, when you're typing passwords, using a mask attack is very, very good at cracking passwords, because it turns out people choose very, very common masks. So what if we can just block those? So these are 3 of them. And it just takes an array. So you basically can do upper, lower, digit, and special. Define your mask that you don't want allowed, and Gavel will block that, or it will fail on it. The next one is one-word base. It's actually kind of I'm going to say quote algorithm that I stole from Jeremy on the hashtag forums. It's basically a way to take a string and try to see if it has a base word in the middle. So it's pretty simple, probably could do some improvement. Basically, we'll strip off any special or digit characters from the beginning and end, and then it will convert any special or digits to a letter that they map to an editable need speak method. And then it will use Redis to look up that word to see if it actually exists in the English dictionary that's in there. And then the next one is blacklist. So it uses, you basically can feed Gavel, it's Redis memory cache, a word list. So if you have a word list like the Rocky list, the LinkedIn list, etc., you can feed them into Gavel, and anytime a password is in those word lists and you submit it to the password complexity service, it will tell you that it failed because it was in the block list. So I didn't want to sit and let this run during the demo because it does take a little while to actually feed in something like Rocky to there. You know, it's very simple to run. You basically, it has a node script that runs over a word list, and you give it either English or blacklist. So if you want to put your English dictionary in the Redis cache, you say English. If you want to put your words in the blacklist, you say blacklist. And I have provided on the repository an English dictionary. And so to take every single word in Rocky, you split it up and then put it into Redis with the script. It takes about 8 minutes. And this can be done while the service is running. So ideally, you can have the service running on your network, and as new word lists are released, or you crack new word lists, and you know that the attackers are going to be using those word lists, you can just keep feeding it into your cache. Now, Redis it's in-memory data store, so you might need a beefy box. With Rocky, it runs on my laptop, so and it's 8 gigs of memory, but you might need a beefy server if you start feeding it, gigs upon gigs of word lists or something like that. Okay, so okay, so first thing I'll mention, since I know people are going to be kind of freaked out, is that this web service can run with HTTP or it can run with TLS support built in. Okay, so it does run with TLS, so it's just about as secure as using a form on your web page or something like that. You can just start it with HTTP because I recommend with Node specifically. It's not the great at doing encryption itself. That's better suited for a server like Nginx. So you ideally should run it on HTTP and then only allow like a reverse proxy to talk to it and then encrypt over that. So I'm going to run it now with HTTP, but it does support out of the box. So if you gave it a key and a cert, it would just run it with HTTPS. I need to start the server first. All right. Okay, so now it's listening here. So let's feed it some passwords and see if it works. So the idea of Gavel is that since it's just running as a web service, you can have all of your web applications that you're designing tie into the same service. And so if you're a security engineer or something for a company, you can tell your developers, hey, we're going to use this service. You need to make a call to this JSON API, and then use that. Don't let the developers code up their own password complexity requirements, which are probably very, very simple. You can also tie analytics by writing a PAN module, or you could tie in your Active Directory domain by writing a DLL. So if someone is looking for something to contribute, a DLL that people can put on their Windows domain would be really nice. So yeah, it's just a post request with the password. So let's give it password 1. Okay, so you can see that password 1 was in the Rocky list. So maybe we give it something, maybe we submit it outside. Oh, it's in the Rocky list too. Damn. Okay, so you can kind of see how this progresses. Node is very cool that it lets us run all those checks, not in parallel, but concurrently. So there's a difference between parallel and concurrency. But it's able to check that very, very quickly is what that boils down to. And so you can see that, okay, it found password that's based off of a single word. Let's try a key locking example here. So, key locking. what you'd expect. So does anyone remember what the masks were? What I had?
6 lower special digit.
I think I had yeah, six lower special digit, right? Okay, cool. So 6 lower special digit. 6. Right? Yeah, so, oh yeah, good key walk, right? So yeah, you know, you can see that, if we were denying these maps, so, you know, you could put all like the common hashtag maps maybe from a certain word list or something, or get them from someone and block any type of password that can have that. So it would make an attacker's life much more difficult. And then for the last demo, I'm going to give a really, what I think is actually a pretty good password, but you tell me if it's going to pass. Does anyone think that will pass? No. Why?
Words.
Okay, yeah. Well, words? Like what do you mean words? Like it has words, but it has 2 English words.
It's super susceptible to the types of cracks that people in here do all the time. Adam's that's crack. Because basically you take a hybrid, he's got baddest, he's got bitch, so you do a hybrid there, and then you just tack on number 1. I watched him do this.
So if a user came to you and said, so let me ask you guys this. If you were to crack this password, would you say, oh, that user chose a really bad password, or is this a kind of okay password?
I would put it okay. But
like our requirements will say, like, don't base it off a single user, or don't base it off a single word, have a number, have a digit, and then, you know, so it's 2 words, the number and a digit. That's pretty good.
The problem is you got the special character and then 1
at the very beginning.
That's what makes it really bad.
Okay, well this does get blocked. And there's a reason, is because this was an Iraqi list. And so kind of my argument, the point I was trying to make here is that if passwords are being leaked by other sources other than your own, and your users might be using those sources too, they're going to just use the same password, but also if they're leaked in clear text, it doesn't matter what hashing, they're not using a hashing algorithm. So they're going to end up in an attacker's word list. So if you can fight their word list by using the same exact words they're using, you can block seemingly okay passwords, but that would still be discovered.
Can you give us something that passes? You know,
Oh, yeah.
like your own password, for example.
Well, why don't you give me your password, and we'll see if it passes. Does anyone have a password? You just want to roll my face on the keyboard? No, So, pass.
10 dashes.
10 dashes? Well, 10 dashes would fail because it doesn't meet the complexity requirements.
And that one failed because it would get written on a sticky note.
Sticky note protection is not provided. But you know what? It's on Git, so if you want to submit a pull request for like a too complex password at the end of that. Okay. So, in conclusion, this is on Git. It's open source, like I said. I don't intend to be a password complexity expert, and I probably never will be. I really like just breaking stuff and doing like things like building applications and breaking applications and things like that. I don't have really much interest in complexity or even password cracking all that much beyond what it helps me do. So if you would like to go check out the code I have and find problems with the algorithms that I've developed, or even develop more, I'm sure there's some great ideas in here about how we can build like a strength meter and then have some sort of number limit or something like that. That'd be great. So it is open source, so feel free to go. Yes.
Is the innovation here the fact that you are actually using banning specific passwords as opposed to doing these entropy things, or?
The real reason why I thought the idea was novel, or I thought the idea was original, is that it was language agnostic. Meaning you could deploy this on your enterprise, or heaven forbid if someone deploys a third-party service, you can trust them. I don't know. I know Jeremy, I think, was going to do it, but I wouldn't trust him.
Oh, yeah, I was going to do it.
Does anyone deploy an actual password meter that's based on blacklisting?
I know. So I know there's some paper. I know there's some paper ones that exist.
Yes.
So is that part of Windows specific? So I know there's some Windows specific ones that will let you define blacklist. I don't think you'll be able to define it as large as this, but I think it's like a few words. So maybe your company and things like that. So there are some third-party services that will let you do it with paper service.
Well, Paragraph Talk that pointed out that Twitter, I think, has 7 words that they
I
blacklist.
think it's 1,000 word list, right? But I think so. Yeah, if you actually look at the source code for Twitter, I think that is entirely in memory on the client. So certainly not an original idea of banning a blacklist, but a blacklist this large, I haven't seen anywhere else. And like I said, being language agnostic to me is really important in that you don't have to depend on every single developer, every single system, or every single admin doing their own password complexity. You can just say, hey, you need to use this service. Okay. Yeah.
Are you familiar with ZXCVBN project?
No. Did I steal our idea?
No, you did not steal it. I think you guys can get things together really nicely.
Okay.
That's one from a Dropbox, right?
Yes,
Yeah.
yes. And blacklists, while anything coming out in 1Password 4 is beta tentative, we don't know, but the built-in password strength meter in that uses a 10,000.
Okay. Cool. Yes.
So is the idea that enterprises would run this in-house and so therefore?
Yeah, the idea is that even if you had, enterprises or people who are taking in users' passwords and want to do a very good job of complex requirements. Certainly, I think there's some difficulties there. Like if you're Twitter and you start deploying this, people are going to be upset because they're not going to be able to use all their favorite passwords. So there's some explanation to go on, say, hey, we're doing this and why we're doing it. Yes.
If someone was to just grab this and turn on all the options, what percentage of the password space becomes banned?
Sorry.
I'll tell you 0%. I mean,
Guys, this is turning into a discussion, so I think we should break it off that, and we'll do a 7 minutes break while we just arrange a few things here. And next speaker up again is Autumn, Hashcat again. So thank you, Tom. 7 minutes.